Hey guys, welcome back to another video. So, I spent all day polishing this, and I think it's coming along very nicely. So there's quite a bit to show you. This is like the third time trying to make this video, so we'll see how this goes. Render distance is currently on 20, so this might take a second or two to fully load the map in. You can see the bottom left, it is loading everything. It's running in the 2D chunk array basically. So that's pretty nifty. So it'll be done at about 3, 2, and 1. Nice. Okay. So you can see in this tiny window, I have a light test running. And this is very cool. And let me just Alt-Tab real quick. So let me show you this. And it's going to be in Chunk Mesh, right here. So what you're seeing is a combination of hardware and software lighting. It's defined by the software, but the GPU will take it over by using the, I'm going to get it right this time, the fragment shader. So you can see this is on this light with a max level of 16. 0 is complete darkness, 16 sunlight. So, we go back into the game. You can actually press the F button, and that frees your mouse, so you can maximize the window. You can actually press the WASD buttons, but you can't turn in this mode, so you just press F again, and it puts your mouse back in. So let's get up somewhere pretty high. And hopefully you guys noticed I polished the inertia system just a little bit. You can see your character actually has some weight to them. Also, I polished the game loop to be more precise. So now the game loop, at least in the collision detection and the player detection aspect, it is running at 60 FPS while your frame rate of your GPU can outrun that all you want, just to be like, my game could run at 700 FPS. Okay, we're pretty high right now. You can see how far this is rendered. This is a little ridiculous. I'm not sure why the color of the blocks turns like whitish on the top. It's very strange, but I'll probably figure that out. So let's walk over here. We'll just kind of walk around the map. I'll show you guys how this system feels. You can see that it's actually pretty snappy, and for some reason it's like lagging a little bit on OBS. Let me check the OBS settings. Yeah, OBS was actually, that's the problem. Oh no, I forgot to press the F button. There we go. Oh man. Pre-alpha development bugs. So you can see how precise this is. You can only jump when you touch on the ground. So what happens is you can't do the mind test float bug, where the collision detection is really floaty. And that's just my preference. That's why I wrote this like this. I like to have the collision detection be very solid and not feel like mind test collision detection with that bug feels kind of mushy. It's very strange to explain, and I know it's because it's a very a versatile engine. If you don't like it, you can change it. It's like kind of like baked into the engine. So I was like, how can I avoid doing this? How can I avoid mush in the collision detection? And I tried my hardest to make sure it never happened, and it seems like it worked. So, all right, let's walk over here. You can see, I think this is, let's see, can I find a good example of this? All right, here we go. This is darkness 0, or light level 0, and this is light level 16. And the reason why this runs so fast is because when the chunks are generating, it may have light levels in the actual chunk data, but that gets sent to the GPU and it applies a color um, shading to it, and the color shading is set equally. Let me press F so the mouse doesn't go crazy. The lighting is applied evenly to the faces, and what I can do is actually unevenly apply this. This is why I left these variables open. So let's just get my mouse back in there. So, needless to say, it's going to be a bit dark in a cave. You might want to bring a torch. And I'm going to manually, I know what you're thinking when I say this, but I'm going to manually code in the torch model because I want to see how the modeling is with direct Java implementation, so I don't have to, not only so I don't have to use Blender, but so you don't have to use Blender. I can make my own simpler version of a block modeler and bake it right into the main menu of this game, basically. So you can do custom stuff like that. Yeah, I think that would be a good idea. I have no idea I'm going to be able to do that. So you're going to have to wait a little while for that, because that's going to take quite a while to develop. That is literally creating a new interface to modify and then making the game run within that scope with the switch statement. But other than that, I think it'll be pretty easy to implement. I want to try to get the torch style for Minecraft, but use the models that I did with Crafter and Minetest. I had like a complete brain fart. I've been programming too long today. So, anyways, after I put the torch in, I'll experiment with doing some basic like particle systems. I want them to run really fast, so I'm going to do a bunch of experiments with them. So we'll see how that goes. And hopefully you guys can visualize how precise the collision detection feels. Because when you're actually moving around in here, it feels like the blocks are substantial objects. So on render distance 20, it takes a very long time to walk one side of the map to the other side. Yeah, this takes like forever. So needless to say, even in a static state, there is still a lot of stuff to explore. So I think that's pretty cool. I'm going to create, or I'm going to attempt to create a block class, and you can define meshes within them. So I'm very excited to do that. But I think the lighting is more important for me to implement first, along with the GUI system. That tutorial I implemented, this is the tutorial that I implemented, the entire tutorial I showed you guys in the last video of our updates. But if you want to learn how to program in Lightweight Java Game Library, I strongly recommend you read that book because it's very informative. And that's how I'm going to learn how to program the OpenAL elements into this. Oh my goodness, there's still more map to explore. What else is there? I think I was saying something else and I completely forgot what I was saying, but anyways, I want to implement lighting before I implement custom block models, because I think that would just work a bit better in the long run. Because the first thing is done. This feels like some pretty solid collision detection. The game loop feels pretty solid. It doesn't lag. That's my main goal of writing my own engine, and it was successful. And it's very precise. It paid off. But I want to implement more things on top of this base engine. So we'll see about that. So anyways, I'll just kind of fall off the side of this real quick so it'll get sent back to the center of the map. And we'll walk to the top of that hill right there. So yeah, I just like to reiterate, you can see that even if you don't jump properly, like you clip the side, you'll just kind of slide as if you were hitting it like this. And that's just what I'm used to from from Minecraft, because I used to be a Minecraft junkie back when it was in alpha and beta and whatnot. So this is actually kind of nostalgic. um, I'm sure that Notch did some tests like this when he was creating Minecraft, but I think this looks kind of cool. Oh yeah, I'm not. I did 3 of these video attempts, or I attempted to make this video 3 times. I can't even speak anymore. I'm not sure if I showed you guys this in this video, so let's see this. So you ready? And you're ready. So it looks like I'm pretty much facing the same direction. I'm just moving my mouse very slightly. So you can see that inertia is the main instancing of the collision detection. And I did this for a number of reasons. Mainly, it's not only inertia, it's also localization of your position based on what you're colliding with. And this is to create lightning fast collision detections. And this is because I wanted more precise collision detection. Again, with Minetest being mushy, I don't know why I walked away from that like specific example I had, because I was going to show you guys something. Let's see if I can find another one. Oh no. Not quite. There we go. So in Minetest, and yes, I got my signature yawn in this video. In Minetest, if you do this, you'll always go to the right or you go to the left depending on what axes you're facing. In this one, you can also go to the left. So I think that's pretty nifty. That's just to allow more abstract collision detection, essentially. More, I wouldn't say realistic because this is a block game, but more like common sense collision detection. Yeah, we'll go with that. Also, if you notice with the jumping, you actually jump slightly over the block when you jump up. So I think that's pretty cool. So we'll just kind of jump off of this, and I'll show you guys that that's not clipping if I go down it, which is going to be great when you can mine and build, because clipping, I remember clipping used to be a problem a couple months ago in the Minetest engine. That was very super annoying. It was very annoying. So hopefully this makes everything better. The only real change I think I'm going to do is, you know, I'm not going to show you guys the code for this one, but let's just visualize this like this. Let me get a flat surface. Okay. So what's happening is whatever block I'm standing in, there is a 1 block radius essentially. So it's 3 by 3. And then it goes from your base position, which is located at 0 of your actual position, because technically what's happening is you're clipping into the block below you, so that becomes position 0. And it will cycle through 4 blocks high, so it goes from 0 to 3 basically. And so I'm going from the bottom to the top. I think if I go from the top to the bottom, I won't have to implement my hacks to push the player away, because in special scenarios you can actually clip the side of a block, and I think a way to fix that would be to actually just kind of push the player away by indexing up to down, basically. So collision detection is very complex, and I have no idea if I would be able to explain that, so I'm not even going to attempt to. Let's just say if we come into this scenario, let's pretend there's nothing down here. But if that block's missing right there, and that block's right there, there would be a block underneath it. And so if I didn't have the hack that detected if there's a block above it, essentially you just clip it like this, as if you were standing on that block, basically. But it works for now, so I'm not complaining. Also, if you made it this far to the end of the video, congratulations. If you'll notice, the frames per second is much higher. Also, I limited the camera, so now you can't do that. The rotation thing that I showed in the last video. But yeah, the frame rate, even with no culling, the OpenGL throwaway mesh, built-in things, it's still doing render calls for everything that's behind you that you can't see. I do need to do frustum calling for that, which would make the frame rate even better. So we'll see about that. What else is there? I think that's literally it. I think that's all I got. I'm probably going to end the video and be like, oh, man, I should have explained that part too. Let's see. I feel like what I'm going to do is program the actual objects in as a singularity and kind of do something special. I might make a shader element to add to it or whatever, so I can take one object in memory and draw it everywhere or something like that. I'm not sure. Because the one thing that slows down Minetest in Minecraft is the basically render calls, and that's okay, that's expected. But I'm just wondering if I can figure out a way around it. I'm not sure though, because what you're seeing right now is a lot of hard work that I've done, like a lot. That's why my videos are so spaced out right now, because I'm building the base of the engine. It's very difficult. But once the base of the engine is built completely, I will be able to do more frequent videos, basically. So yeah, anyways, I want to try to drop down as many render calls as possible and see if I can do that. I really want to get torches in here, and I really want to get raycasting that's proper in here, but we'll see. Oh, also, if you press forward and backwards, it stops you, and if you press right and left, it stops you too. And also, let me just show this. The inertia system works great. I love that. Let's see if I can get it to do it. It's really difficult. There you go. I finally got it to do it. I'm actually really happy about the collision detection. That's like the 5th time I've showed you guys this video. Anyways, we're on 18 minutes and 30 seconds. I'm going to end the video here. Hopefully you enjoyed this. Hopefully you enjoyed walking around. The link is in the description. In this video, I'm just putting the lightweight Java game library test because I'm thinking about just making that the crafter repository. I don't want to do that yet, but we'll see. We will see. So, anyways, guys, have a good one, and thanks for watching.